All right, so my name is Lance Brandenburg. I'm the solutions architect at Geist Interactive. Outside of FileMaker, on my good days, I can play bogey golf. Bad days, probably triple bogey golf. At 1 a.m. when I can't sleep, chess.com is my preferred app. I haven't gotten better in a year, so if anyone wants to beat up on me, feel free to look that up. And I'm gonna have a baby girl by the end of this year, so we'll see. Thank you. We'll see if I can be productive with no sleep come December. So today we're talking about testable FileMaker apps. So my goal today is actually to pique your interest in testing. I'm only going to talk here for 10 to 15 minutes, and then I'm going to move, and we're just going to do demo work. I'm going to try and show you some complex examples, some simple ones, kind of walk you through it. Everything you're going to see here today is available to you in the session materials, so you can download that. I wouldn't necessarily say try and follow along. If you can just pay attention and then play with it later, there's kind of a lot to digest for parts of it. So we are going to have time for questions at the end, and we'll get into that. If you could just wait until we get through some of that demo work, I think that'd probably be the best way to get through it. So why do we test? If any of you as developers kind of identify with this picture of a guy playing whack-a-mole, you already really know the issue, right? All too often when you're working on a complex app, it feels like you can hit one problem in the head only for another one to pop up over here, and then another one there, and this kind of just goes around and around. So the reason we test is that we can build durable solutions, okay? So we can prevent regressions, and you as a developer can get peace of mind knowing that you aren't breaking critical components of a complex application when you're implementing changes and new features. System specifications are really vital, and testing, I'm gonna argue, is a better way of storing system specifications than any of the other available methods. Also, testing allows you to have an alignment of the system along with the intent. So really what we do as custom developers is translate a business need, right? A piece of logic and their intent, how should this application work, to building an application that does work that way, right? Now as FileMaker developers, I think the FileMaker platform kind of allows clients that have frequently changing needs a great opportunity to implement those changes, okay? Now we know as developers, one of the issues there is that as you implement changes frequently, your system is liable to break, particularly as it gets more and more complex over time. So let's start talking about regression testing. So regression testing really gets to the core question, what can you change without consequences? Has anyone rolled out a new feature, right? And then you realize that you broke something that was working 6 months ago all the way through. Has anyone had that experience? It's really common, okay? This isn't unique to FileMaker, this happens all over the software world, and the solution to regression is regression testing. You find a way to test in code the things that actually work, so you can build up that knowledge and maintain it over time as you add new features. Additionally, testing will give you peace of mind. And I think that this is kind of a subtle benefit of testing. It answers the question, how'd you do? So you get a feature request from a client. You go to implement that. How many people have ever had the experience where you know that you've given the client the feature that they requested? When you go to deploy it, you're not really sure what the other things are that are gonna change. So maybe you close your eyes, and you click it, and you sit there and you wait. And you wait for that phone call, and then the phone call comes in from a user telling you just broke something. It's a terrible feeling, right? So testing solves that problem for you. Another subtle benefit is it's actually gonna speed up the development time. And I would argue that actually that anxiety that we have as developers of not knowing, we have significantly better tools, right? So I'm at Geist Interactive, so of course I use FM Perception. So if I roll out a new feature, I can tell if I change a field definition, all the places that field is referenced, right? What's absent is that I can't necessarily tell what was the original intent when a developer implemented it that way. So even though I can see all of that, I can spend a great deal of time trying to do my research, maybe make some assumptions, then I roll out changes, but we have blind spots, and that's a problem. So let's talk about system specifications, and I want to talk about how that works currently. So the possible formats that you can have for storing system specifications, which is a collection of knowledge around how a system ought to work. The most obvious example is writing. We all saw in the keynote that you had like a 3-ring binder, right? The binder for that event management. If you actually have something like a binder that tells you how a system ought to work, I think we all know the shortcoming of that. If you have a system that's changing frequently, now you have a separate project that has to be maintained and aligned with your actual code. Maybe you use like a wiki or other advanced online tools for data collection, but again, it's the same problem. And that problem is twofold. One is it's a separate project that has to be maintained. But the big problem with writing is that it has to be read to extract that information back out. So let's say that everyone in here, every application you ever worked on had a perfect manual, and we all read it. We would actually get slightly different ideas of how that's supposed to work because the English language is really sloppy. So another place that you can store specifications is in your client's mind, right? Sometimes you don't write it down. Sometimes the client just knows how things is supposed to work, right? Well, there's a problem there too, which is that your client is a human. Humans have blind spots. Humans forget things. Humans forget why they did something to begin with. And as you start talking about more and more complex system, we're not even talking about one person that's supposed to have the knowledge for this system. We're talking about many people collaborating, coming to an agreement about how a system is supposed to operate, right? And so really the human mind is not a reliable place to store this information. Another place you can store it is a developer mind, right? So that's way better, because we're all super smart. No, it's exactly the same thing. We forget things, we're unreliable, we really shouldn't be trusted. And I would argue that at any point, if you actually do solve someone's problem, it's flippant, in that you know how to solve that problem for maybe a week, maybe a month, if you're really good. And I know we've probably all had the experience of like coming back to code we wrote a year ago. Sometimes we're embarrassed. But sometimes we're like, yeah, I totally remember how I did this. And that's great. But that's not your experience over and over again. Sometimes you come back and look at your code and you aren't exactly sure why you did it that way, right? These are actual problems. The FileMaker platform is actually so powerful as a rapid development tool. Sometimes specifications are stored nowhere, okay? And that can be a real problem as your system grows in complexity. So why is testing better? The first thing that testing is it's executable, right? So what that means is rather than having a big document or a wiki or something that you have to go read, or rather than doing mini discovery where you have to go track down people and get knowledge from them about how this thing is supposed to work, what you actually end up with is a script you can run that gives you a thumbs up or thumbs down. Did you meet all these specifications? Depending on how complex the system is, it could take seconds, could take minutes. We haven't done anything that takes hours. I guess it would be possible, but that would be a lot of testing. Another thing about building something that's executable, if you can put your specifications into code that's executable, that means it's shareable. So let's say that I was actually on vacation, and I've been working on this project for 6 months. And the client comes in while I'm on vacation, and they say, we need a feature pushed out tomorrow, right? And so I have to pass it all the way up the chain, so now Todd Geist has to take this one. But he knows that he's told me I have to build tests for all of my core business logic. And so he implements a change, and he can run a test. And at that moment, I've transferred 6 months worth of knowledge that I know I had to safeguard in order for that application to run, and given it to Todd in a matter of moments. This isn't even possible with language, right? Computers can do it faster. If anyone here is an auctioneer and think they can talk fast enough to get through that, your mind isn't going to be orderly enough to remember all of it. So if we can put it in code, that's where it should be. The last point that I'll say is that it actually makes it enduring. So because I put it into code, and because it's executable, and because it can be transferred from one person to another, that knowledge can now live on within that system for months, for years. So if you actually have complex applications with complex business rules, which I would argue is the whole point of FileMaker. If people have simple business rules, they can probably buy off-the-shelf software. So what's the problem that we're solving for people? They have complex issues. They have to take those issues and build a set of complex business rules, and they're going to rely on their system to enforce those business rules so that they can use their systems effectively. So testing actually makes that possible. So let's talk a little bit about how we create testable solutions. The first thing I want to talk about is modular scripting. Now, modular scripting is an entire session in and of itself. It's an art form. It's something that as developers, you're just going to get better at over time. If you aren't familiar with it, you should be. Modular scripting is not something that you do in order to test. Modular scripting is something you do to maintain complex systems. So if you're building a complex system, you really need to make sure that you can reuse your code and isolate it into discrete units. So this is a really, really simple kind of graphic that I created. But we'll say that functions 1, 2, and 3 would all just be scripts within your solution. But they all complete one thing, one discrete piece of logic. Unfortunately, I can't give you a cookie cutter definition of what discrete means, and developers will argue. I will argue within my own team of exactly how this should work. But trust me, there are people that don't do this correctly, and then there are kind of experts who build modular scripts and then disagree about small things. That's where you should get as a developer. So here you have functions 1, 2, and 3 are independent. They always do the same thing. And then you would have something up top, like script 1 calls function 1 and function 2 to get done what it needs to. Script 2 is calling all 3 of them, right? So these functions, these things down here, they're actually reusable. That's what modular scripting would mean. So Geist Interactive released a CRM framework called Carbon. And we actually do something interesting within that architecture, which is we have an interface file and we have a controller file. That controller file is actually a separate FileMaker file. This is not the data separation that you might be used to, where you're talking about having an interface file that's local and then the data off the server. Both these files are on the server. And the reason for this is that the controller file is the one that's going to hold all of your business logic. If it's something that's vital to a business, how do we create purchase orders? How do we change statuses? What does it mean if it goes from A to B? That logic needs to be in the controller. And the reason for that is simple. We have gotten to a point now that if you use JSON in and JSON out, which is the #1 rule for our controller, is that it's basically taking a payload and it's returning a result, right? And the reason we do that is that a FileMaker client, a FileMaker Go app, WebDirect, you can have a web application. They all can interact with that vital business logic using the same language of JSON. So as you build up your client's logic this way, it's reusable from anywhere. And if you have someone, a user in the 3rd slide panel over, and they need to create an invoice from there, that's fine because it's happening in a hidden file that's the controller. And as a developer, this is a game changer. And the reason for that is that when you work in the interface, there aren't as strict of rules, right? If you want to actually go in and change some things or validate some code or do things, that's fine. If it's in the controller, it's transactional, it receives JSON, it returns JSON. And the only elements that we test for are in controller. So I'm not saying that testing, I don't want to set an expectation that testing is going to fix everything. Conditional formatting, a user perceives a little icon, right, as being the wrong color and does the wrong thing. Those things will happen, that's user testing. That's not what I'm covering today. What I'm really talking about is vital business logic. You put it into modular scripts, it's discrete, it's accessible from anywhere, and you can write tests to make sure that the conditions that that logic performs are met over time, executable and shareable. So the last thing I'll come back to is if you want to get started on testing, I would recommend that you adopt some custom functions. So this was all basically handed to me from Todd Geist, and he was the one that came up with these custom functions, and you guys are going to see them shortly. Those custom functions aren't required. You actually could complete testing without using some of these custom functions, but it's a major, major benefit, and I would recommend that you do that. Those 3 open source libraries, by the way, are available in the session materials as a link. You can go to GitHub and download them now. So let's start with demo time. So I'm actually going to start kind of at the end. So I want to show you the benefit of testing up front. So what I'm going to do, I have a local copy of Carbon here. So when we shipped Carbon, it's a lot of files that you can see here. And I'm going to open that. I'm going to open up Carbon Tester. Okay. So this is what a Carbon test file looks like. It's what your test file should look like too. It's a separate file, right? And I'm going to give you the developer experience first. Then we're going to walk through some actual examples. So let's say that you just came into a project and you're working on some Carbon implementation, and you as a developer need to do some work. So step 1 would probably be, I want to make sure that all these tests are actually being met. So you just click play. It starts running those tests, and we get our results. So what just happened, right? Well, we have a code base inside of Carbon that actually takes tests, it packages up JSON, it sends it to the actual controller script. Those controller scripts perform their function. They return either a result object or an error object as JSON, and then we evaluate that to make sure that the test actually worked. So let's say that you started there, and you had a request. Now I'm going to open up Carbon Controller. So this is the file that I was talking about that houses all of the vital business logic. This is where everything that's testable lives. So let's say that you got a call that for some reason when you create an activity, that it's adding in a date in that controller file no matter what you send from the interface, and that this is a problem for some reason to one of the users. So no problem. You come down here, you find out in our text transformations, don't worry too much about the code, we'll get into this in a little bit. And you go down here and realize that if the date is empty, this script is actually setting it. So you just comment that out and tell the user, no problem, I just fixed it for you. But you're smart enough to know, you know what, everyone's using testing now. So what I want to do is come back here before I roll this out, and I'm going to run this test. So what just happened, right? You can see there that red line means we have a test that failed. This is really important. And I want you, if there's a moment that you guys can take home, realize that what just happened. That test that just failed is from another developer's rule who was on vacation with their feet in the sand, who didn't have to be called, didn't have to do anything, and you as a developer implemented a change, realized you were going to break something historically, and you got a warning. Is that cool or what? You'll see too that we actually get some information. So it should have a path activity.date that returns 8.8. And if we look inside of here, we'll see that the date was actually empty, right? So what happened with this test is we packaged up some JSON, we sent it out to the controller file, we got a result back, and then we looked at it and we said, you know what, this doesn't meet the criteria of the test, okay? So that's incredible because you're still on vacation as a developer and you don't have to tell anybody else what happened, and if you're the developer implementing the change, you got to it in an instant. Now this runs really quickly right now because this is all local. I didn't want to have any network connections. This testing can take a little bit longer over the WAN, but it is pretty quick as you saw. So that's all I'm going to show right now for our Carbon, but again, that is an open source tool that we've released. You can go download all the testing, all the file, and look at it, and it does have all of the modularity, all those features that you would need are available in Carbon. So let's actually go to part one. So I created something that I just call simple file. So this also is available in session materials. So what I want to do is actually kind of walk you through the mechanics of what it requires for something to be testable, and then we're going to walk through how to test it, okay? So this is not a very complicated file. It just doubles numbers. Can you guys see all this, by the way, in the back? I'm only going to be able to zoom a little bit. So as you do this, I'm sure that everyone can grasp pretty quickly what's going on here. And I want to actually bring you through the scripts. So we have two folders up top. One is called interface scripts, and one's called controller scripts. Now this is in the same file for the simple example because I just wanted it to be accessible. So let's look at an interface script. So the first thing that an interface script does is it packages JSON. So we've called that param. And what it's going to do is set something called number to whatever's in that field, right? Number in. So that's this field here. Then what we do is we send that JSON to another script. Now this pattern's going to be really common if you adopt the style of modularity that we're using with Carbon and building all of our custom apps. So you basically have something that packages up JSON, sends it to that controller. It's going to execute a discrete piece of business logic, and it's going to kick you back either an error object, which is JSON, or it's going to kick you back a result telling you everything went okay. Now, can anyone think of something that operates this way, where you just send it a payload and get back a result? How about the internet, right? How about every API that you've ever worked with? This is basically how they work. And we do frequently call those controller scripts API scripts. So what we're effectively doing is building APIs for our solutions that are accessible by JSON. So you send that, and then that script result is going to come back. You take that script result, and then you handle that result. Okay? Package up JSON, send it to the controller, get that result, handle that result. So in this case, all that I do is I check to see if it's an error, and otherwise I'm going to set the field number out, so that's the one that we saw on the right, to whatever we got back, script result number. Okay? Now we do have one rule here. So it's -5. If we put any negative numbers, it's going to return 0. Okay? So now you can imagine what the controller script looks like, right? It's really simple. It just takes that thing and multiplies it by 2, and we're done. No, we don't make things easy. So this is actually a common pattern as well. This is a controller script. So this one is really taking in JSON, right? So that first thing that you see here, we have param JSON.format is the first custom function that I'm introducing you to. What that does is if it's not, and let's actually do a live sample here. So I'm going to send an empty parameter. So let's get script debugger going. Open up my data viewer. So we're going to set the parameter to nothing, and then we're going to call that script multiply by 2. When that happens, on this very first line, we take the param, we do json.format get script parameter, okay? And when we do that, this is what we get, an error object. Now that custom function is important because json.format works with our error codes, so you want to adopt all of these so that we can handle what type of object this is. So if you pass something into our controller script that's not JSON, we return it right back as an error and say, no, we don't allow that. Okay? So let's look at another one here. Let's say that we just send the wrong print. Well, if we send text, it does the exact same thing. So you're going to just get errors back. Give me a sec. Okay, so you're getting that same error code. So these scripts are tightly controlled, right? You can only send JSON to them, and if we don't, we're just exiting immediately. So let's do, if we send the wrong parameter. So in this case, we're sending number. I want to see if anyone can tell. So the first thing we do is set the param. Now at this point, that parameter is number, and it equals 6 for this script. Now we have this function error.isError. What that does is it says, if this object param is an error, meaning it wasn't JSON, we're going to exit. In this case, we did get JSON, so we're going to continue. Now, what we do after this is a json.validate. And we'll look into this in a little bit, but really what it does here is we're going to verify that the JSON that was sent in has a key called number. Now, I just stepped through that. Does anyone know why we got an error object here? The expectation is, what's that? No, it's actually because the expectation, oh, I should have showed you this first. I guess you would have to be a mind reader to know. So in multiply by 2, when we walk through these, this JSON validate, by the way, it looks like a lot. There's a few custom functions all strung together. But essentially what you do is right there, we're saying that if you want to start processing this script, we're still in the validation block, you have to have number, capital N number as a key. Oh, sorry. So now this code right here, you can look at this and say like, man, how am I going to remember all that? You don't, just copy it. It works the same. We have a few rules. JSON validate rule is required, is number, is one of. They're all really self-explanatory. They work pretty much how you'd like. So this is the problem of how do you validate a JSON payload, right? If you don't do it this way, you end up doing a lot of things around, okay, if then this, and you try and set custom errors. This makes it so it's basically declarative, meaning you get that one line here where we set this error object, and it goes from there. So I've shown you a few ways that it can fail. Let's actually just look at what happens when it runs. So we package up a parameter, right? Because it's coming from the interface file. We send it to JSON, param is set. Okay, we walk through there, that's not an error. Then we run past this. At this point, error code is 0, because now we've actually sent the proper key in our JSON payload that this script expected. So it's going to let you continue. So at this point, we actually grab as a variable. If people have used let notation in the past to pass multiple variables, we basically always will have a variable block here. So you can see as a developer towards the top of the list, whatever JSON was passed in, these variables get instantiated here. So you can basically read what's going on. So that number exists now. Let me go over to current. So this is basically what we've created. We have the number of -5, and then we do a little piece of logic. If the number is less than or equal to 0, we're going to set the result to 0, and then we exit script. Now the important thing to know is when we do exit this script, we're sending JSON back, right? This is always a feature of a controller script. So this is a very dumbed down piece of business logic, but you can imagine that it would have done something complex. You need to send back a result that the interface expects. So we do set that, and then in here, we set number out, and we're done. So that's a really quick review. And the whole point of this file, what I've just showed you, the simple test file, is just to understand how you package JSON, how the controller validates that JSON, then the controller processes things, then it returns the result, then the interface processes it. That's a common pattern. It's how we're going to do controllers at Geist Interactive from here on out. It's how we build complex things. And the whole point of that is because the controller side is what you can control. It's what you can test for. It's where your discrete logic lives. So now, let's take a look at the testing file. Okay. So just like I showed you with Carbon, I have a little test file here that just tests the numbers file. And I only have 2 tests in here right now. So the first one is 5 should return 10. And if you read through these, you can kind of see what's going on here. So let me zoom in. This is all something that you write as a test, and we'll get to that really shortly. So it should be valid JSON, shouldn't be an error. We have a property number, and it should have a path number that returns 10. So what we're doing in the test is saying, hey, when we send this stuff, this is what I expect back. And if it doesn't meet that, I'm going to give you that thumbs down, that red line, saying, no, something here is off. So let's open this up, and we'll start by looking at a test. So this is behind the scenes, this is what a test looks like in its simplest form. So up top, we just have variables, test group, test subject, test case. Those are all pretty obvious. So you as a developer, this is open to you. Whatever you would like to see in the results is really how you can define what's on the right side. These variable names, we actually do have dependencies on the assert functions at the bottom, and we'll get to those momentarily. So what we do is we kind of define the test here, what the result's going to look like. We take data. This is what we're packaging to go test that thing in the controller file, right? We're building a parameter. It feels an awful lot like the interface, right? That interface file packages JSON, sends it to controller, gets a result, and does something with it. With tests, we're packaging up JSON, sending it to the controller. So when you actually create things modularly this way, it's very easy to test because you can write in data here, this is what a user might do, right? So you're actually getting these discrete pieces of logic that are testable because you, when you're building tests, can essentially do what your users are going to do in the system. So in this case, oops. So then we call the script, multiply number by 2. It's important to notice that I'm calling the script that was in that controller, right? Not the interface scripts, because those are not testable. Then again, we get that test result. And then from here, we have assertions. So what do these assertions actually do? Well, this is actually what's creating the object that displays in the end, right? So when you see the thumbs down red line, that's defined here. So we're going to do, and again, I think these are pretty explanatory. Assert valid JSON, assert that it's not an error, assert that it has a property, right? And in this case, we're making sure that it has the capital N number coming back. So an important thing is that we sent number, right, with a capital N. Well, you guys might notice, people who have done API integration work, you don't always get what you sent back, right? And again, when you build your business logic, when you build your own controller scripts, you define it. You define what should go in, you define what should go out, okay? What we've done with our custom functions is make it a lot easier to define your error objects, to validate JSON, do all that. You're still defining what comes back and how it gets handled, okay? These assert functions are going to actually take that and produce these objects. So has property number in with a capital N, that's because I'm actually returning that same thing. And then we make sure JSON path equals. That's just saying that not only does it need a number coming back, but because I sent 5 and this function doubles it, that needs to be 10. So if we were to change any of this, so let's say that I change that to where the expectation would be 11. And then we ran this test, it is going to fail. So you can see here that really as a developer, you have to take all of your assumptions, build them into code, and now we kind of have something that's durable over time and accessible to other users. One thing that I'd say too, so this is an interesting test. You can see on the left side that I have pass and fail. How many people here in your solutions ensure that your scripts fail properly? Okay, that's good. It can be a difficult thing to do, but if you error trap and handle those errors, you need to make sure that when you put something into production, when you error trap, you need to actually handle the things that are going to happen in a real environment, right? So what happens if it's a record lock and you're trying to set a field and then it fails and you capture it with an error? Those types of things are things that you should handle. What you want to make sure of in a testing environment is that you make sure you can build scripts that make sure something fails properly, okay? So this one I just call no parameter. And what I do is I'm just building this up saying, okay, no parameter should return an error. I package up data as nothing, and then I send it over, get the script result, and here it's valid JSON and assert.error. We're making sure an error comes back. We can't have scripts out in the controller that are returning success when we know with this payload it should fail, okay? So what I'm gonna do, the script that I run is called run tests. I already have this one queued up. So no parameter, and let's run this one. So now you get no parameter down here, and that one succeeded. So we know that that script works. If we were to come back here, this is kind of a common error when you start working. Let's say that you accidentally sloppily put an exit script with nothing as the result. Let's run the test. It's telling you, nope, there's something wrong with that, okay? Now there is a paradigm that people have across a lot of different languages called test-driven development. And let's do a little example of that right now. So what that means is that if a customer gives you a specification, I need a feature to work this way. So let's say that a client calls and says, you know what happened today is, some smart aleck put, 1.0955, a long thing in there, and it came back and just doubled it. And we can't have that, so we need it to be to the hundredths place, okay? So what I actually want to do here is let's just build a test. So I'm going to copy negative number. I'm just going to call this one hundredths place. We'll leave it as numbers. We'll call the subject. We'll just do DevCon 2018. We'll just say live dev never works. All right, so now we need to be able to test this case scenario. So we'll just say 1.09. So just throw in a long number. It's already defined as JSON number, so we're good there. And then we pass this along, multiply number by 2. So then let's go through our assertions. So in this case, we need it to be not an error. So that valid JSON, not an error, has property number. And what would we need the path to equal? So we're saying that we need it to be 2.02. That'd be really embarrassing if I got my math wrong. It's possible. Stressful up here, guys. Okay, so we've actually done that. So I've created a test making sure that there's a condition that should be met, and I haven't touched the production code. This is actually an important thing because I would say as a developer, we actually have a state of hopefulness at all times that doesn't suit us well, right? We build something and we hope it works and we walk that narrow path. One nice thing about doing this, making sure your code fails properly, is you change as a person. You're trying to figure out how to break stuff, and that will lead to more durable solutions as well. So I'm going to run this test. Oh, I forgot to add it. Let's run it again. All right. So it failed right now because I haven't made the changes to production yet, but that's good, right? So let's go into our production file and see if we can actually get this test to pass. So I'm going to come to multiply number by 2, come down here. What we'll do is just do a simple round. And let's run this test again. What do we get? 2.2. Jeremy, you're right there. You could have told me. I knew that math was going to be off. Thanks. So what we need to do now, if we come back here, another thing too, this is actually really helpful. You'll figure out, was the test wrong or was the math wrong? In this case, the test was wrong. So run that test, and now it's going to give you the right answer. So we actually started from that point of view of, hey, the customer told me something, I'm going to build a test, then I'm going to go change my code until that test passes, right? That's like a healthy way of looking at things where I think it can add some skepticism to yourself as a developer, change your mindset a little bit. All right, how are we doing on time? So that was our simple file. I want to move on to something a little bit more complex here. So the sample here that I've created is a pretty simple purchase order system. okay? Now, we're kind of scaling it up, so you're gonna see all the same design pattern that I introduced to you with that simple number file. Now it's doing something a little bit more functional that you can kind of understand intuitively better. There's a few things to know about this file. So basically, this purchase order file is the interface file, and we actually have a separate one for the controller. So this is going back, it's like that, like the Carbon framework that we started with, right? Now you have two separate files. And if you start looking at this, you'll notice over here that we have business logic. I really would encourage you to try and open this file, make up purchase order rules that a client might give you, and then enforce them. There's a few in here, but it's not much. So in this case, you package something up. Let's say we're gonna make a new PO, and I'm gonna just turn on Script Debugger so we can walk through this. So we're gonna say that the vendor is Geist Interactive, right? We have a date in there. So what's gonna happen? This should look really familiar. We're gonna commit these. This table is called utility purchase order. So how do we package up JSON in the interface file without creating records? Well, how we do it in Carbon, in a lot of cases, is we create what's called a utility table. It's one table that's full of globals that can be used by the user to package up JSON and send it to the controller. This is really nice for a few reasons. Has anyone ever had a case where a user, let's say you just let people click on new record. Has anyone ever seen someone click new record multiple times, and now you just have blank records, right? Well, let's say you have a piece of business logic. The one thing that you can do is say, oh, you know what we're gonna do? We're gonna require this field. Or you can go into the data and say, I'm gonna validate this, and I'm gonna write a statement in there, right? Well, that doesn't work across maybe different user types, maybe they have different rules, maybe there are things that you wanna change, and that can get really complicated, right? If you package up JSON and send it to do like record creation and record edits, it's actually a really nice format to keep those things controlled. And if it does fail, because it's transactional, that means that we revert the record in the controller and nothing happened. Nothing got created. So problems that you may have seen where a user creates a record, doesn't validate well, maybe there's a blank record in there and then they try and delete it. But you have, controls in place where they can't delete records. So now you've created a job for a database admin that gets to go delete the record on their behalf, right? But it's not nearly as efficient. So this pattern, you'll see it in Carbon. I've done it for a lot of my clients. I think that it's really nice, and a lot of the benefits of it, I think you'll see. So at this point, we don't actually package the JSON in the script. You'll see that what I'm passing is utility underscore purchase order, and then we have a field called as JSON. So I'm gonna stop here and let's have a look under the hood and see what that is. Okay, so this is a pretty simple little table. There's nothing complex going on here. But this as JSON calculation is really just a JSON set element for the record that you're in, right? So as the user starts adding in a status or a date or choosing a vendor, all those things, these global fields are basically being set by the user. It's just packaged up into this field. And we can send that one field as JSON. So the JSON's a representation of what that user packaged up. And you can send that over to controller. So in this case, let's go again. Geist Interactive. I'm gonna hit save. So we go through here. I'm gonna just hopefully skip over this. I hope I don't have breaks. So at that point, that's the script step that actually creates a purchase order record. And it actually created a purchase order status because that was all handled in that controller file. This thing comes down, it looks at the script result, it realizes that the script result that we got, let's look at this in the data viewer. Okay, so it realizes that this is what we got back from that controller, right? So we know that that's a good record. The record's been created, everything we can continue. And in this case, all that we really do is close the window, enter find mode, go find that record that was just created. Okay? Now you can see here in the status history that these are the related status records. So if you ever have a client that here's POs, but we kind of have this complex workflow around statuses, right? That it goes from new to submitted to approved, canceled, denied, things like that. That we actually get a history in here of here's the related records. Now all of that was created on the fly, and you can kind of come in here and see the rules of this. So when we do create purchase order, so that's the script, Did anyone see Todd's modular FileMaker talk yesterday? Okay, so he spoke about FM docs, which is another GitHub repository. I probably should include for you guys, so I'll do that on the session materials. FM docs is really a slight change to JS docs, which is it's like a Java notation for how to define parameters for a script that are readable. So we use that in this file. We use that in Carbon as well. And there's a few things to know. We'll get to that pretty shortly here. So when you walk through create purchase order, it's the same stuff that you've seen. We're going to validate the incoming JSON. I'll try and zoom in a little bit here. We parse the JSON into variables. Then we do transformations. So it's doing the same thing you saw before. If you didn't pass in a date, we're going to assume it's today. If the status is empty, we're going to set the status to new. And then what actually happens down here is we're going to call a subscript. So one thing that you're going to get for free, if you guys have used transactions before, one thing that's a bit challenging is still how you have discrete pieces of logic that call other discrete pieces of logic, and it might do a few things, right? Well, the module that you're going to see in Carbon, and it's available here too, is the transactions module. It solves a lot of problems for you. And you can copy and paste this code. You kind of just have to go through it. It's not the most intuitive thing the first time that you look at it. But what it enables you to do if you use transactions is, one, if the problem I talked about before with record locks, if something has a record lock and attempts to set and you get an error, you can pass that error all the way back up. And we actually have scripts. So a complex example is you can do, like if there's an inventory system, let's say you're pulling out gravel, and there's kind of like a complex accounting problem of how do we value that gravel, like first in, first out inventory, so you have to pull the lot and the original purchase price, and then based on the volume, maybe it's 2 receipts, and you have to average up. There's kind of a lot of stuff that can happen. And so there's a lot of discrete pieces of logic that you have to call on and pull that all together. Each piece of logic does its own job well. You pull all of them together, and you can actually let someone with an iPad just check out some gravel, and all of it's solved. And what's interesting is if you have a script that calls a script that calls a script that calls a script, which we do in this case, and then this one throws an error from a record lock or something when it's trying to make an edit or create something or whatever, that error gets passed all the way back up. We revert record, and none of it's created. This is absolutely vital. And so that module is really one of the core features of Carbon. It's available in a simple way in this file. So this file here, all right, I'll try and be quick. So I do want to open purchase order tests. So this one has its own test file. We can run these. Now you're going to see there's really more commenting here, but it's mostly the same thing that you saw in the simple file. So up top, right, this is all just the testing scripts. You can kind of see the intent of the script. We set variables, same exact thing, test group. Sorry, forgot to zoom in. I have a really big display. I don't know why I'm struggling. So test group, test subject, test case. Then we have something called initial conditions. And if you look in this purchase order file, it's probably the best place to see us work on initial conditions. And I'll run through this quickly. I know I'm introducing a lot of concepts, and I'm sorry, but I know that some people out there are probably wondering how to handle this. So sometimes when you need to perform a test, let's say that you want to make a rule that says, you know what, if I have a purchase order in approved, it can't go to submitted. That's a request that came to you from the client, right? That's just a business rule they need to enforce. Well, to test that, you need to have a record in the system at the point you call the test that's going to be in that state. So initial conditions actually allows you to just create records and define things in the database that need to be there in order for you to perform a test. Now, you could build a testing engine that didn't rely solely on scripts, but Todd told me no early on, much to my chagrin, and I have realized that is the right move. And the reason is the scripting engine is incredibly flexible. So you could have needs where you need to re-log in as a different user before a test, right? What if you have a particular privilege set that isn't supposed to be able to create POs? You could actually re-log in as that user, try and create a PO, and make sure it failed. You could try and create a PO as a different user with the same exact payload and make sure it succeeded. You're actually successfully testing to ensure that for the user that shouldn't have access to create a PO, it's working properly. It's failing. It should fail because they don't have privileges, right? So that's an important part of it. Everything else here, you run the script. So this is going to look really familiar. You have your payload, run the script, you grab the result, and then you have assertions. Now I know some of you are looking at this going, hang on, I have to write all this production code, then you're telling me I have to go into tests, which is just a developer tool, and I have to rewrite a bunch of code. And it can be a little bit repetitive. So what we've done, this isn't by any means a complete tool, but I do have something that's also in these called test generator. And what it does is it gives you a really basic framework just to kind of define this using an interface and generate these script steps. So in this case, we're going to say, so let's say that I have my JSON payload down here. So I have the vendor name is blank. We kind of have a date in there. And what we want to do is make sure that it's going to fail if we don't pass in a vendor name, right? So you just go down here, and I've defined the group, the subject, the case. It'll grab which script you're looking at. And that's actually pulling it, by the way, from that controller file. The reason for that, again, all the scripts that are testable are in the controller file. So we click Generate Script Steps. Cross your fingers. So when I hit paste, what we should get is a test. There you go. So this is a really good template. It defined everything for you based on what was in that interface record. It calls the script appropriately. It does set this. Now, a lot of the times, this is the first thing that you're going to need to go edit. So having a date may not be the best idea defined statically. So maybe you'd want to do get current date. This one happens to be a failure, so it doesn't really matter. But it sets things properly. So assert.error versus valid JSON. And just so you know, we'll set up a new one. Let's say that we wanted to test for a success. And we did test. And in this case, we want to make sure that the result has a date, has a vendor name, and that vendor name should be test. I'll go ahead and generate those script steps. Come back over here, and you'll see that we actually get that here. So it is taking things that are actually in that JSON block and just automating that for you, where you can paste it. Everything's fully editable. You can add your own initial conditions. You can define your own parameter. You can do all that work. But this is really a good template to know what a test should look like. And then the only other things that you have to do is once those things are created, so let's say this auto one, we actually want to add in. So you do need to remember that you kind of have scripts that just call a series of tests. The reason we do this is sometimes in a complex system, you're going to have a lot of groups of scripts. You always want to run all of them before you deploy to a new server. But there are going to be times that you just want to deal with the series. So let's do this one. Go back here. OK. And this is the one. So it actually did succeed. So our code is operating properly. If you don't pass a vendor name, it will not create a purchase order. So that's pretty cool. We're getting to question time. So I want to show you one other thing that we've produced for you. So I'm going to go into this controller file. And this goes back to the JS docs. So one part of this is that if you see these square brackets, we're basically saying that is optional. So for this API, you can pass in date from, and that'll be inherited. Or you can leave it blank, and we'll just kind of fill it in for you. So this is a common one. These here that don't have the square brackets are defined in these parameters to be required by the API. Okay? Now, one common thing that we want to do with tests is make sure that what was intended in our FM docs, so in this top area where we define the at param, we need to make sure that what's here actually fails. So if something is data.status and it doesn't have square brackets, what that should tell us up front before we even look at the code is the intention of this script is that if you do not pass a status, it's going to fail. It's going to fail the validation, that top part, before anything even starts happening. So again, that's something that we can automate. So we have a function up here that just says failure scripts. So what I've done here is I've copied to my clipboard, right? Status and purchase order are required. I'm going to come over here. I'm going to just click on failure scripts. And if I come over here to tests and open this up, fingers crossed again, paste. So now we have two tests. And these tests right here actually filled out the group and subject and case, all of that, because we know that we're testing for failure based on the clipboard. We set the data. So the data in this case says that we're missing param status. You'll notice it's not in here. And we can actually run these tests. I'll just add one of them for the sake of speed. There you go. Cool? All right, so at this point, we only have 8 minutes left. If anyone does have questions, I kind of would like to start a dialogue if anyone's really curious about something. If nobody has any questions, I could kind of dig into some of the initial condition stuff, but I actually would prefer questions.
Hi, so I think this is great for the controller file. It does make testing kind of possible in FileMaker development in a nice methodical way. And do you find, what sort of scripts do you end up with in the interface file? And how much work do you have to spend testing those, and how do you test them when you're using this system?
Like, how do you test the?
Well, like, in the interface file, you will still have some scripts.
Yeah. What
do they look like, and how are those tested?
Sure.
When you're using this?
Yeah, so we don't test interface scripts, and that's not because errors cannot occur there, right? You can make mistakes, and we do. And so you roll something out, there's still things that users will be confused by, and there will be problems. This isn't user testing. So really those interface scripts, for the most part, it's only the complex business logic that needs to go to the controller. So a lot of the time in the interface, if you have something like a first name, you're just working in the field and editing it. So we're not saying everything has to go through controller, but the interface scripts really are like, if you had a business rule that you can't have Mike for a first name, it has to be Michael. Well, now you're talking about a piece of business logic, and we send that to the controller. So our rules for the interface file is essentially that if you're going to allow a user to edit a piece of data, do it. There's no need to do all this controller work. But the moment that you have a piece of logic that's vital to the system that needs to be controlled, that's going in controller. And we don't do controller stuff by default. It's kind of, you start building, and then you're going to realize, like, this should be transactional and modular and called from anywhere. So then we move it to controller, then we write tests, and then we know that we have that piece of logic ready to be controlled. Did that answer your question?
Yeah, that's brilliant. Thank you.
Okay.
I just wanted to kind of clarify on your sort of model of interface and controller file. Do you store the data in the interface file or in the controller file, or do you have a separate data file?
We're freaks. We have a lot of files. Let me show you here. I got Carbon Local. We actually do have a file called Carbon Data.
Okay, so you separate all that.
It's a separate one, yeah.
Okay.
And a lot of that comes from OAuth has really enabled you to make it easy to have multiple files. And really, we kind of have rules by file for you as a developer. Depending on what you're doing, you know which file to go work in.
Right.
And it's a little bit foreign, but it really solves some core problems. I think one thing that's easy to do is conflate what it is you're doing. So if you design an interface file and then you add a script trigger that does something that's supposed to set a cached field, and then it sets one cached field and then it fails on another one because of a record, like things like that really aren't reliable when you get into multi-user scenarios and complex systems. And so you kind of know when you're designing in the interface, like, okay, if I'm caching fields, controller. And so you kind of develop different patterns. We haven't necessarily agreed at Geist Interactive exactly how those patterns should look in the interface file, but we are very stringent on what the controller file looks like, and that's really what matters.
Okay, so do you always separate the data, or is there ever instances where it's right in the interface?
I didn't do it for the purchase order file that you have. I didn't do it for the simple file.
Okay.
For our clients, we do separate it.
Okay.
And there actually are a few good reasons for that when it comes to having table occurrences and calculations. So what the relationship graph in all three files is going to look different. So in the data file, it's not exactly like an ERD, but it is basically charting out how your data is related. And there's typically one, maybe two table occurrences for any given table. Okay. When you look at the interface file, we use selector connector. And so we're kind of integrating everything and setting it that way. And that you're really free to add table occurrences in the interface file to accommodate your needs, kind of as a UI designer. You're really doing UI work there, and you don't have to worry about the business logic. And then the controller file, I won't get into it, but it has its own structure that's completely different from anything you would see in the interface file, and that's vital to being able to do things transactionally.
Okay, thank you.
Yeah.
So really cool, thank you. Test-driven development kind of answers this, and it really changes the way I look at things. That's got to be really helpful when you build the test first. Like that's a wild way to think about FileMaker development. But I'm curious, in your experience, if you have a bug in your test script, and then you test it, and now you go build business logic that passes your test script. Now you've got a bug in your business logic, and when you got to go debug, now you got to debug your business logic and your test script. Now that's a lot of more complex debugging that you've just dug yourself into.
Yeah, I think that to answer your question, I guess my answer would be that you're always up against how clear of a solution do you have in your mind as a developer, right? We're the translators, where it's like a person just says what should happen. We have to build the interface and then the logic to make that become part of the solution. If you as a developer can't get that clear, right, you're gonna have bugs no matter what. And it's really at the time that you build kind of the logic, if you should be building tests to go with it. And if you do mess up tests, it should be obvious to you at that time. And the nice thing about these tests is that it's when you're at your peak. When you're at the zenith of understanding this problem that you're working on, this feature, that's when you build your tests. What you've said is perfectly true. If you have bad tests and then you build your code on top of that, you're gonna build bad features. But the idea is that at that point, you're really the only person qualified to build that feature because you've spoken with the client, you know their expectations. You're the one whose responsibility is to implement that. So really, it's a responsibility as a developer. You just have to be good enough to have everything in order in your own mind. But once you translate it into code, it just kind of lives on.
So basically the benefits outweigh the, maybe occasionally you'll add an extra problem, but since you're doing it at the optimal time, you get more benefit out of the test.
No, absolutely. And I mean, you know, Todd built these things about a year ago, so we've been implementing it and doing things over time. I'm really hoping today that you guys found this interesting enough that you'll go play with it and actually start doing it for your clients. Because I think that we would all benefit from talking about these types of issues, like what's an issue with testing? What's something that happened that went wrong and how can we prevent that? And really, I think that testing solves a fundamental problem, not for FileMaker, but for software. There's a good reason that other environments have testing environments on top of whatever their development platform is. And I think FileMaker would benefit the same way. And we probably have issues that are unique to us as a community, and we should just talk about it openly and try and share and figure this stuff out.
That's awesome, thank you.
Yeah. Are there any other questions? 1:59 on the dot. Thank you all very much.